All right, let's take a look at your next lesson, which is word problems with rational numbers. If you head to your page sorter, let's go up to the top. Today we're going to be looking at learning goal number 17. I'll be able to solve word problems involving rational numbers. So up in your table of contents, go ahead and fill out the date here, as well as learning goal 17 for the word problems section. Okay. We're going to head back down to today's lesson. Let me get rid of the page sorter, and here we go. So we did word problems in the last unit. You're always going to see these in every unit you do pretty much, just because they're a great application of your skills and learning goals. And so there are a lot of similarities. You want to be noticing patterns as you go, so that certain things become familiar and not as tricky to you. So a couple things to remember. We are trying to notice anytime something asks how far something is or what's the change, or also another common word is what's the difference. Please remember that that is subtraction. And so for these, we're going to have the end minus the start in order to find that change, okay? And so, again, if you don't know, if the story problem itself doesn't really have an end and a start, you're just still going to take the two numbers that are given or that you create and subtract them to find the difference. The other option are those where expressions. And so if they're saying, where are you now? What's the new position? Where's the new location? Or basically, you already know. So if you know the difference or the change, then you're doing this. And this is going to be addition every time. Okay. Now, it might be addition of a negative or addition of a positive, but either way, that template will work the same, or that little formula there. So it's going to be your starting number, and you're going to add the change, okay? But that change could be a positive or a negative, okay? So just be aware of that in your problem, okay? So let's go ahead and take a look at these word problems. You're going to have to think a little bit deeper with this. There's a couple ways you could solve it. I'm going to show you one, but you could come up with it through a couple different methods here. So I'm going to be reading this. We'll take some notes as we go. Amanda just finished her undergrad degree at Penn State and has a loan of $160,000. This is a debt, okay? Because it's a debt, that means she's in the negative. She's in the hole. So I'm going to make that note right in my word problem here. She found a short-term job where she makes this amount per month. So this is sort of important to realize that per month means times however months that she's working. She also decided that she's going to take 1/3 of her monthly earnings. So 1/3 of something also means multiplication. So another thing to be aware of. So she's putting 1/3 of her monthly earnings toward her loan. Amanda's short-term job's only going to last for 2.5 years, so that's important. And then it says, what will the balance of her loan be after the 2.5 years? So they're basically asking, what is that end location or end number? So it tells me that this is a situation where I know what the change is going to be. This is going to be a where type word problem. And so I already know I'm going to end up doing start plus the change, okay, to find the ending balance, okay? Now, it's not going to be as simplistic as just I know the start and I know the change. You can see there's a lot going on here, so we have to sort of problem solve through that. So either way, I know my start is $160,000, okay? And so there's my start. The only thing is this is a negative 160,000, so you need to make sure that you are clear on that. Let me just rewrite that so it's super clear. So negative $160,000, okay? So that's my start, and I'm going to add the change, okay? And now I need to figure out how to write the change as an expression. And so I can see we have 1/3 of her monthly earnings. Okay, so it says we have 1/3 of her monthly earnings. Her monthly earnings are $2,530.50. Okay, so that will give me the amount that she's paying on. Now I also need how long that's lasting. And so if it says that it's going to last per 2.5 years, I need to think about what that is. So let's look down here. I know 1 year is 12 months. Okay. 2 years is going to be 24 months. And then 2.5 years, then we're just going to add another half. So that's 6 more months. So we end up at 30 months total. Okay. So essentially now I know that if I look at our expression here, we start with negative 160,000, and then we're adding 1/3 of that monthly pay that is going to exist for 30 months. And so I can put that 30 there. Okay. So now I have a couple options here. Okay. If we think order of operations, we have to, we're thinking PEMDAS, I have to do my multiplication before I do the addition. Okay. Now, however, okay, this multiplication that you see here, because of the commutative property, I can do that in any order technically. If there was division involved, I would have to do the multiplication first from left to right. But I'm going to make some different decisions here based on what I see. So the first thing that I'm noticing is this 1/3 times 30. That's a nice, easy one for me to do because I know 1/3 of 30 is 10. You can also look at it like this, 1/3 of 30 over 1. You can see when we do that cross-simplifying that they simplify to 1 over 1 and 10 over 1, and we end up with 10. So that's what I'm doing there when I'm saying 1/3 times 30, or what's 1/3 of 30. And so I end up with this underneath, 160,000 plus, and then 1/3 of 30 is 10. Okay. So, and think about that too. 1/3 of my total income over 30 months is the same thing as just 10 of the full income. Okay, so that's why that simplification works. All right, so now I can go ahead and do 10 times that. I know that trick where when I'm multiplying by 10, I can just move the decimal point to the right. And so I'm going to go ahead and do that little trick and move the decimal point to the right to make the number 10 times bigger. And so now I know I have negative 160,000 plus, oops, not going to be 2,000, 25. Let's just write out the number first and then move your decimal. The decimal's right there. Count over 3, and there we go. We have 25,305. And so here we have a negative number plus a positive number. So we do our song, same signs, add and keep, different signs, subtract. And so we're going to subtract the 160,000. Okay. In this case, because I'm doing the trick, I can just do my 160,000 minus 25,305, but I know my answer is going to be negative. And we have subtraction across 0, so I'm going to go all the way over, take 1 less, 9's in the middle, and add 10 at the end. And then I can go ahead and subtract. So 9,876, 9,876, 4, and 5, 4, 3, and 1. Okay, and I know because of my note, I didn't forget that I have, this is actually negative. And so I end up with this information at the end. Okay, so I know I have negative $134,695. And it says, what will the balance of her loan be after 2.5 years? Her balance will be negative $134,695. Okay, so that's how much she owes at the end. Okay, or if we're looking at it as far as how much she owes $134,695. Okay, however you want to think about that phrase. Okay, you could also write she owes $134,695. Okay, so same type of thing. All right, let's go ahead down to this next one, and we'll problem solve the same way. So this person has this in ELA. To me, that seems like a location and a point. That's a positive number, so I'm going to take a note at that. Okay. We also have his mom's super excited for the grade, so Danny decided that since he's doing so well, he can miss a few assignments. Bad idea, Danny. For each assignment he misses, his grade decreased by the same percent. So this is important. There's an equal amount of decreasing going. Decreases by the same percent. So, and he missed 9 assignments. So we know that they equally decreased. So we could figure out how much each assignment contributed to that. Danny now has this amount. Okay. This is also a positive number. And it is another location. How much did each assignment change his grade? So we're wondering about the difference between his grade, but then specifically, how much did each assignment change his grade? So you have to understand that little twist. After we find the total change, we want to know how each of the 9 missing assignments changed the grade. So there's a little twist there to be aware of. Either way, this is a change problem. So I'm going to do end minus start. So if you make sure you're writing those little hints in that template there. So my ending percentage was 68.4%. And I'm going to subtract the start, which was 94.5%. And it's going to tell us how much the change was. Okay. And that obviously it did decrease. So I'm going to go ahead and do a quick keep, flip, change, KFC there, and go ahead and solve this. I see different signs subtract, and so I'm going to set that up, and I have 94.5 minus 68.4 would line up the decimals, but they line up naturally anyway. 5, 4, 3, 2, 1. Do a little regroup there. 13, 12, 11, 10, 9, 8, 7, 6, 8, 7, 6, 5, 4, 3, 2, and we have a 26.1% change, and pay attention to your sign. So different signs subtract, keep the sign of the bigger digit. So this is just, the negative is just telling us it was a 26.1% decrease. Okay, we went down that amount. Okay. All right. So normally this would be our answer. Okay. This is the change that occurred. Okay. But in this case, they want to know how much did each assignment change the grade. So I know that there were 9 assignments. And so we need to divide up this percent into those 9 assignments to see how much each assignment changed the grade. And so we're going to set this up. And we have 26.1 I know it's negative, so I'm just going to mark that a little bit, divided by the 9 assignments. I'm going to put my negative up in the quotient right away so I don't make any silly mistakes and forget. And then I can sort of ignore this down here. Okay, so 9 times what gets me close to 2? Nothing. What about 26? I know that 2 times 9 is 18. 3 times 9 is 27. So it's going to have to be 2 times 9 is 18. And then we have the subtraction here, and we have 18, 28, 27, 26. So a difference of 8. Bring down the 1, and we're at 81. Make sure my decimal point is brought up. 9 times 9 is 81. And so I know that'll finish out that problem. And so here's my official answer at the end, which is a negative 2.9% was how each assignment affected his grade by not doing it. So I can go ahead and put my answer up here, negative 2.9%. And then we can write the answer. So always reread the question first. How much did each assignment change his ELA grade? Each assignment, I'm going to say reduced his ELA grade by 2.9%. Because I said reduce, I don't need to put negative 2.9%. Okay? All right. So you can see essentially they have the same template of identifying what kind of problem it is. And they do work. You just have to also be really thinking about what it's asking you before just grabbing numbers and doing things with them.